This is 1988, number 45. So they give us the volume of a can is 16 pi. So if we have this can, the volume of any shape is the area of the base times the height. Well, the area of a circle is pi r squared, and the height of the can is h, so that's the volume, but they tell us the volume is 16 pi. So I put 16 pi in place of volume, and once you cancel the pi's out, you're left with that equation. But we're not done. It says if the minimum amount of tin is to be used, so the minimum amount of tin is to be used to make this can. So what determines the amount of tin? It's going to be the surface area of the can. So what makes up this can? This can consists of two circles, the top and the bottom, and it includes a rectangle, which is just the side of the can unfolded. So if you were to take the can and slice it here and unroll it, take that and unroll it, it would lay out flat. So that's the area of the can. Well, the area of a circle is pi r squared, and you have one on the bottom also. And this can, this distance here is that distance. It's the height of the can. And then the distance around this, if you unroll that, that's the top of the can. And the circumference of a circle is 2 pi r. So the distance around the can is the circumference, that's 2 pi r, which is the width of that rectangle. And this is the height. So the area of this rectangle is length times width, so it's 2 pi r times h. So that's going to be the area of this. So now my area formula, I have 2 of the pi r squareds, and I have 2 pi r h. And what am I trying to do? I want the minimum amount of tin. So I want to minimize this area, so that occurs at critical points. So I need to find the derivative of that. But I have a problem. I have too many variables. I have r and h. I don't like that. But that's where this other equation that we had earlier comes into play. I can solve for h. So I'll divide both sides here by r squared. So I have 16 over r squared equals h. So I can take this value of h and plug it in here, and I would get this. And one of these r's will cancel with one of those r's, and I will get this. I'm going to multiply the 16 and the 2 and get a 32 pi, and I'm going to move the r to the top so it becomes a -1 power. Now I'm going to take the derivative. So 2 pi is a constant, so I copy that down. And the derivative of r squared is 2r. That's a plus, not a equals. I don't know why I put equals there. And 32 pi is a constant, so I copy that down. The -1 moves in front, and the power decreases by 1. So there is my derivative. And let me write this down, simplified. So it's 4 pi r minus 32 pi over r squared. A lot of work. Let me combine these two. I want to get a common denominator of r squared. So I multiply the top and bottom by r squared. So I get a equals 4 pi r cubed minus 32 pi over r squared. So I had a common denominator of r squared, so I put that there. Now I set the top equal to 0 to find the critical point, that's derivative. 4 pi r cubed minus 32 pi equals 0, because that's a critical point where the derivative equals 0. I'm going to factor out 4 pi. That's going to leave me r cubed minus 8 equals 0. And then I set r cubed minus 8 equals 0. I get r equals 2. Add 8 to both sides and cube root. So that's my critical point. Now you might say, hey, if r equals 0, that's going to be a critical point also because it's undefined there. But think about it. Your radius is 0 is the extreme case. That's the endpoint. Obviously, you wouldn't have a radius of 0. And so partly on a multiple choice question, it's got to be one of these. So it can't be 0. So my radius, obviously my radius is 2. But what's the question asking for? It's asking for the height. So I know it occurs when radius is 2. And again, why wouldn't I check to see if that's a max or a min? I don't have to because that's my only critical point. So that's got to be the answer. R is 2. So if you plug a 2 here, 16 divided by 2 squared is 16 divided by 4. H would come out to be 4. That's got to be the answer. Since it's a multiple choice, I don't have to prove it. I only had one critical point. R is 2. I don't have to check it. So the height has got to be 4.